So string replacement fields can also contain formatting to display values with a specific number of decimal places, for example. So let's create a new Python file. I'm going to call it formatting. And I'm going to use a for loop to generate some output. We'll be looking at for loops in the next section, so don't worry about what's happening. Concentrate on the print lines that I'm going to type in this code to see the effect of the formatting in the replacement fields. So we're going to start by printing the values from 1 to 12 with the values of their squares and cubes. So on line 1, I'm going to type for I in range, parentheses 1, 13, and put a colon to the right of the right parentheses. So on line 2, I'm going to press enter here. You need to make sure there's 4 spaces before print, which I'm about to type on line 2. I'm going to type print, parentheses, in double quotes I'm going to type number or the abbreviation NO, period. Then I'm going to put replacement field 0, which is our left and right curly braces with a 0 in the middle, squared is, and replacement field 1, and cubed is replacement field 2. Then I'm going to type dot format, parentheses I. I'm going to use the exponent operator, which is 2 multiplication signs, 2, then I, exponent operator again, 3, which is to the power. It's basically raising one number to the power of another in Python. All right, so if we run this now, and you can see we've got the values of the number, the value squared, and the value cube for each of those numbers. And in case it's not obvious now, you can provide any expressions inside the format parentheses. They don't have to be variables or literal numbers. On line 2, we've got I exponent operator 2 to get the number squared, and I exponent operator 3 to get the number cubed. And the exponent operator is how you can raise one number to the power of another in Python. So it's the power 2 operator as well. All right, so that works, but as you can see, the numbers aren't, or the values rather, aren't lined up. So we can fix that in the output, or fix the output by applying some formatting. So firstly, I'm going to specify field width for each of the replacement fields. So all the values for I are a maximum of 2 digits, because we're obviously only counting from 1 to 12 here. So we can use a field width of 2 for the first replacement field. I'm going to use a field width of 4 for the other 2 fields. So to actually specify width, we come back up to our line 2, and we add the width by putting a colon and then the number that we need. So if the first replacement field is 0, I'm going to put colon 2 there for a width of 2. And for the other 2 replacement fields, I'm going to put colon 4 and colon 4 again. So if we run the program now, it's now easier to understand because the formatting makes it easier to see at a glance what the values are. All right, so that looks tidier. The values are now lining up nicely. So on line 2, we're using 0, colon 2 in our left and right curly braces for the first replacement field. 2 is the field width, as I mentioned, and it's separated from the index with a colon. Now everything in that first column prints in a width of 2 characters. So think of it as reserving 2 spaces on the screen so that the 1-digit values still line up with the 2-digit ones, and you can see that happening there in the output. Now our squares also line up in a field width of 4 characters. Maybe a width of 3 would look better there. Have a go at changing that yourself and see what it looks like. Pause the video and I'll make the change when you come back. Okay, so if we only want to use 3 spaces for the square values, change is obviously easy enough. We come back up to replacement field 1, change the 4 to a 3. And if we run it again, well, that looks tidier still now. As you can see, there's now only 1 space between is and the value on the last 3 rows. We can also align the values in their field width. To left align the values, we place a less than symbol after the colon. So what I'm going to do is, just to make this easy to see, I'm going to firstly add a blank line. Then I'm going to take a copy of the line, of the 2 lines there, and we'll just run it again so the original code's there as well. So I'm going to paste that in as it was before. So this time what I'm going to do, again, we're trying to left align the values. So we'll leave replacement field 0 as it is, the first one. For the second one, we're going to put, before the 3, I'm going to put the less than sign there. And for replacement field 2, we're going to put a less than there as well. So if we run this, and the values are now left aligned. And if it's not immediately clear to you what's going on there, scroll up the output to compare the two blocks. But if we have a look at the formatting here, notice how it's now left aligned. You go back up to the top, you can see clearly that was right aligned. So the alignment symbols are quite visual. The less than left aligns, the greater than will right align, and the caret symbol, well, that centers within the field width. So let's center the last column to see what that looks like. So instead of using the less than there, I'm going to change that by using the caret symbol instead. And if you run this code again, you can see the values are now clearly centered compared to the first output, which was right justified on the right hand side. And this is obviously for the cubed values. Now keep in mind that we don't get half spacing in a terminal, so the result isn't as accurate as centering values in a GUI program, but it's available if you want it. So for floating point numbers, you can specify precision, the number of digits after the decimal point. For our precision, we specify the precision after a decimal point following the width. So let's have a go at doing that. So I'm going to type some more code in. So I'm going to put an empty line in there. Then the line after, well actually line 11, I'm going to type print, parentheses, pi is approximately, we're going to put replacement field 0, colon 12, which is the precision for a floating point number, then dot format, parentheses 22 divided by 7, and 2 right parentheses to close it off. And let's take a copy of that line. We're going to make some modifications, so I need another 5 lines. So I'm going to paste that 5 times. All right, so line 12, what we're going to do is we're going to put an F after the 12. Next line, we're going to put 12 dot 50F. Line 14, we're going to put 0 colon 52 dot 50F. And the next two, I'm going to put 62 dot 50F. And the last line, I'm going to put 72 dot 50F. So the first line of output, well actually I'll run it first and then we'll talk about it. So the first line of output, and that's produced from the code on line 12, and I'll see if I can get that on the screen at the same time, on line 11 rather. Well, that's the general format, and that defaults to printing 15 decimals. When we specify a floating point value using the F on line 12, we get the default of 6 digits after the decimal point. Now in lines 13 through 16, we're still specifying a floating point format, but we also add a precision of 50. And that gives 50 points after the decimal point. The third line of output corresponds to line 13. If you think it doesn't look right, that's because Python won't truncate a number. We can't print a value that's got 50 decimals in a field width of 12. Python decides that precision is more important than field width and ignores the value 12 that we've specified for the width. And that's the code on line 13. Now the next 3 lines after that print the same value but in different field widths. When we specify width greater than 50, you can see that the effect becomes clear. Now the maximum precision of a Python floating point number is between 51 and 53 digits. There's not much point specifying a precision greater than that. Now this will be easy to see if I left align that last line. So I'm going to do that and then copy it and increase the precision just to show you what I mean. I'm going to do that, copy that last line 16. I'm going to change the 72.54F to 72.54F, but we're also going to use the left align so we can see the value left align, and we put that to the left of the 72 after the colon. We run the program now, and what I should do is actually left align the previous line as well, just so you can see the differences. So we'll do that again as well. On line 16, we'll run that again. And you can see we only get 1 extra digit in the output. We can see that there's 4 digits there, but the remaining digits are just padded with zeros. So there's no actual value there. All right, so I'll finish this video now by mentioning that the field number in replacement fields is optional. If they're not specified, then Python takes the value from the format method in order. So to see what I mean, I'm going to take a copy of the code again. This code up here in line 6, I'll take a copy of that again. I'm going to paste it down here on line 19. Now I'm going to actually remove everything. So we're just going to put just a left and right curly brace only for the 3 replacement fields. And actually what I'll do on the third replacement field, I'll just put a :4 there so we can see that we're still specifying a width. If we run this, we can see that the third field shows that you can still use a colon to control the layout even if you haven't specified a field number. All the values in the final column of output are printing in a field width of 4. Now if you don't provide field numbers, you can't use a value more than once, nor can you change the order in which values are used. Now our earlier example with the number of days in the month wouldn't have actually worked without field numbers. Alright, so experiment with different values for the field widths and precisions to see how it affects your output. And I'll see you in the next video.